Hi, welcome to Bookie. To unlock more world-class bestseller, please download our app. Just search for BOOKEY at Apple Store or Google Play. You will get 7 days free trial with more features. Today we will unlock the book Peak, Secrets from the New Science of Expertise. In 1762, Wolfgang Amadeus Mozart began a tour around Europe. His first stop was a palace in Bavaria. As a 7-year-old kid, his feet were far from reaching the floor, and his hands were barely able to reach the piano keys. Nevertheless, he fully convinced the audience of his ability through his performance. The Bavarian aristocrats were thoroughly amazed by his virtuosity. But this is not the whole story of his talent. Little Mozart was able to identify the sound of any musical instrument, and tell whether it was the A sharp above middle C or the E flat below middle C. It's like seeing a car rushing past and being able to accurately tell whether it's going 58.2 or 61 miles per hour. This kind of ability even overshadowed adult musicians in Mozart's time. Now, people call it absolute pitch. It is exceptionally rare. Many great composers and virtuoso like Brahms and Stravinsky didn't even have it. On average, only 1 in every 10,000 people have this gift. This seems to be a perfect example that proves only a few lucky people have innate talents, while ordinary people can only admire them. At least, this was widely believed for 200 years after Mozart's case. However, over the past few decades, people have developed a new understanding of absolute pitch. Researchers notice that there is an important fact that has long been ignored by the theory of innate talent. That is, Wolfgang Mozart's father Leopold Mozart was also a musician. Since he never reached the degree of success he wanted, he devoted himself to the training of his children. When Mozart was 4 years old, his father was in teaching him full-time all kinds of musical instruments such as violin and harpsichord. So, is it possible that Mozart's absolute pitch resulted from acquired training, or in other words, deliberate practice? This theory isn't baseless. In recent years, this assumption has already been proven by neuroscientific studies. In other words, talent is a product of training. Furthermore, this method of training can be traced, which is exactly what the book Peak wants to tell us. This book was co-authored by Anders Ericsson and Robert Poole. Ericsson is a professor of psychology at Florida State University and a Conradi eminent scholar. His research focuses on expert performance in areas such as sports, music, chess, medicine, and the military, as well as the effect that deliberate practice has on them. Robert Poole is a writer of science, technology, and medicine. He has worked as an editor and writer at 2 science publications, including Nature and Science, and taught science writing at Johns Hopkins University. Next, we will outline this book in 3 parts. Let's find out how we can upgrade ourselves from a novice to a master through deliberate practice. Part 1. How does practice create talent? Part 2. What is deliberate practice? Part 3. How to conduct deliberate practice. Okay, let's start with the first question. Why can deliberate practice create talent? We mentioned earlier that according to scientific research, talent is a product of training. Now let's look at another example of someone with absolute pitch. In 2014, the Japanese psychologist Ayako Sakakibara recruited 24 children between the ages of 2 and 6 to train them to have absolute pitch. It was simple. The goal was to train the children until they could identify the pitch of 14 chords. The results were astonishing. In 1.5 years, all of the 24 children completed the training. Besides the 14 chords selected for the training, the children could also identify the individual notes played on the piano. This means that every child who took part in the experiment developed absolute pitch just like Mozart. This was a wonderful and surprising discovery. In short, absolute pitch is not a gift, but rather, the opportunity to develop absolute pitch is the gift. These 24 children proved that pretty much everyone is born with this potential gift. If so, why do some people seem to be more talented? There are 2 reasons. The first reason for this is that practice changes the brain structure, and thus talent can be developed. Now, you must be wondering, is our brain structure subject to change? The answer may surprise you. More and more evidence shows that regular training leads to changes in the parts of the brain that are challenged. The author provided an example in the book. One of the most difficult tests in the world is the exam for a London taxi driver license. Due to the complex nature of London streets, taxi drivers need to have a thorough knowledge of the area within a 6-mile radius of Charing Cross. How thorough? According to official documents from Transport for London, every licensed taxi driver must know off the top of their head the location of all hotels, hospitals, schools, clubs, streets, parks, galleries, diplomatic premises, prisons, and courts. Almost like a walking map. In the time when GPS was not widely used yet, almost every London taxi driver was a memory guru. But in fact, these memory gurus were merely ordinary people. In 2000, Eleanor Maguire, a neuroscientist at University College of London, published her research findings on taxi drivers. She used magnetic resonance imaging to examine the brains of 16 taxi drivers and those of 50 ordinary males. She paid special attention to the hippocampus, a seahorse-shaped part of the brain in charge of memory and particularly spatial memory. The results showed that the rear part of the hippocampus was larger in the taxi drivers than in the ordinary males. Moreover, the longer they worked as a taxi driver, the larger the rear part of their hippocampus was. Now, you may be wondering, is it possible that these drivers were born with a larger hippocampus so they were adept enough to pass the exam and drive through the streets of London? Maguire addressed this issue through a simple but convincing method. She followed a group of prospective drivers at the start of their training. At the time, the size of the prospective driver's rear part of their hippocampus was no different compared to ordinary people. 4 years later, the size of the posterior hippocampus in those who passed the exam had gotten significantly bigger. In contrast, the size of the posterior hippocampus of those who quit halfway or failed the exam had not changed. This research demonstrated that the brain structure of the taxi drivers changed after intensive training, which turned them into memory gurus in the taxi industry. Similar studies have been carried out in numerous fields. For example, researchers have found that musicians' cerebellum is better developed than non-musicians, and mathematicians' inferior parietal lobule has more gray matter, which is positively correlated to their number of working years. Studies in different fields reach the same conclusion: practice changes brain structure and equips people with exceptional gifts that are reflected in their ability and performance. Based on what we've just learned, you probably can't wait to learn how to optimize your brain structure. The key lies in getting outside your comfort zone. If you start to work out with the aim of training for a marathon, you will feel your heart beating very fast while running. This is because your body sends out a signal that you should stop any unusual acts. Only after you have exercised several times will your heartbeat remain stable while running. This means that your body has established a new norm. Likewise, when you try to change your brain structure and take advantage of its adaptability, it is most crucial to get outside your comfort zone and re-establish a norm. That is the first reason why some people seem to be more talented, namely the fact that practice changes their brain structures. The second reason for that is that practice also brings about a change in their mental representations. More advanced mental representations can improve our ability to memorize, recognize patterns, and solve problems. What are mental representations? To put it simply, mental representations are the ways our brains present, record, and process information and knowledge. The more deeply you practice a skill or study a field, the more sophisticated and professional your mental representations will be. For example, when we speak of the Mona Lisa, an image of the famous painting will come to mind. That image is our mental representation of the Mona Lisa. Different people have different mental representations. When we mention the Mona Lisa, some people not only have a vague image of the well-known painting, but can also describe the specific hue, composition, details of the picture, and implications of it. These mental representations can also be somewhat helpful for them to better understand the painting. Let's look at another example. The international chess grandmaster Alexander Alekhine had a fantastic skill. He could play blind. One afternoon in April 1924, Alekhine played against 26 top chess players from New York without looking at the board. During 12 hours of exhibition game time, Alekhine kept track of 832 individual pieces and 1,664 different squares without the help of any memory aid. In the end, he finished with 16 wins, 5 losses, and 5 draws. How was Alekhine able to remember the position of every individual piece so accurately? Scholars have conducted research to study this phenomenon. First, they prepared 2 types of boards. One had the pieces arranged in a pattern from a real chess game. The other consisted of randomly set pieces and had no special order. Next, scholars invited a chess master, a mid-range chess player, and a chess novice to memorize the 2 boards. It turned out that the masters could easily memorize a real chess game, but they didn't perform any better than ordinary people in remembering the positions of randomly arranged pieces. The reason is that, when the masters tried to memorize a real chess game, their mental representations about chess games helped them remember it quickly. What they saw was not the position of a physical chess piece but the chess positions, the patterns of chess pieces, and the interaction among different pieces. They were able to remember it quickly through understanding and re-encoding the chess positions in this way. The way masters process and make sense of chess positions is through their mental representations about chess patterns. The mental representations enable the masters to not only have an overall grasp of the patterns, but also focus on particular moves. They can see both the forest and the trees. Hence, we can assume that Alekhine had an exceptional capacity to remember chess patterns, because his mental representations were more advanced. He had achieved this ability through more than 10 years of professional practice. Okay. That's all for our discussion on the question of how practice creates talent. In conclusion, scientific research have broken the misconception that overly emphasized innate talent, and proved that talent is actually a product of training. Practice creates talents in 2 ways. First, practice can change our brain structure. For instance, the rear part of the hippocampus in London taxi drivers is larger than that in ordinary people. Second, practice can create more advanced mental representations, which improves our ability to memorize, recognize patterns, and solve problems. All these result in exceptionally brilliant performances. Today we are just sharing limited Bookie. To unlock more key insights of world-class bestseller, please download our app. Just search for BOOKEY at Apple Store or Google Play. You will get 7 days free trial with more features.